How does data actually find the right device on a local network? Every machine on a LAN has a MAC address, a permanent hardware name burned into its network card. A MAC address is 48 bits long, usually written as 6 pairs of hex digits. Ethernet is the protocol that carries this data, wrapping it into units called frames. Each frame begins with a destination MAC and a source MAC, followed by the data and a checksum. A switch lives at layer 2, and its whole job is moving these frames efficiently. When a frame arrives on a port, the switch first reads the source MAC address. It writes that address and the arriving port into its MAC address table. This step is called learning, and it happens automatically for every frame. Each entry has a timer, so stale addresses age out if a device goes quiet. When the destination MAC is already known, the switch forwards the frame to just that one port. Every other port is filtered, so devices only see traffic meant for them. An old hub had no table, so it simply repeated every bit to every port. If the destination MAC is not yet known, the switch floods the frame out all other ports. This is called unknown unicast flooding, and it lasts only until the switch learns that address. When the real destination replies, the switch learns its port too, and the flooding stops. But there is a gap. Applications speak in IP addresses, not MAC addresses. Ethernet can only deliver a frame once it knows the destination MAC. The Address Resolution Protocol, or ARP, bridges that gap by mapping an IP to a MAC. Before sending, a host checks its ARP cache for the address it needs. If the mapping is missing, the host broadcasts an ARP request to every device on the LAN. The request essentially asks who owns this IP address and to please reply with its MAC. Only the device that actually owns that IP sends back an ARP reply. That reply is unicast, carrying the MAC address straight to the original sender. Both devices then store the mapping in their ARP cache to avoid asking again. Learn, forward, flood, and resolve. That is Ethernet switching and ARP.